All right, so we're looking at 3.3 today.
Sorry, I have a question. So we did 3.2 last class?
No, I said we're going to come back to 3.2
Oh,
if we have time.
okay, thank you.
All right, as soon as I find my pen. Okay, so we're looking at 3.3. Last class we did 3.1. But I just want to make sure we get through the section that I know most definitely we will need moving forward. So we're going to look at dividing polynomials, the remainder theorem, and the factor theorem. So let's look at the long division process. We're going to erase some stuff and walk through it.
I'm sorry, I didn't copy the first part. Sorry. Okay, thank you.
All right. So looking at the long division process, we have 5,867. We want to divide that by 11. You know, 11 doesn't go into 5, but it goes into 58 5 times. Then we'll take 5 multiplied times this 11. 5 times 11 is 55. Subtract. 58 minus 55 is 3. And we will bring down this 6. That'll give us 36. Then you say, how many times does 11 go into 36? 3 times. 3 times 11 is 33. So the remainder is 3. Bring down to 7. 11 goes into 33. Not 11 goes to 33. 11 goes into 37 3 times. 3 times 11 is 33. And that'll give you a remainder of 4. So the way you'll write your answer is by this right here, what's in the red. That'll be 533 and 4 11ths. And you place that remainder over what you were divided by originally. So just walking through that process, because that's exactly how we're going to divide these polynomials. We're going to follow the same process dividing or using long division on the polynomials. All right. Scroll up, very good. All right, let me erase some of this stuff. All right, so let's look at the first one. We want to divide, we want to divide x squared plus 10x plus 21 by x plus 3. I can erase this too, I'll do all that. All right, so just like before, this x plus 3 will be on the outside of our division sign. Just the same thing, the same way that we had the 11. And this will be on the inside of our division process. Same thing that we had, or the same way we had that 5887. All right. So now you're going to compare the first terms in each. So you're asking yourself how many times or what times x will give me x squared, or what you could do is what we did right here, x squared divided by x gives me x. So whichever way you want to process it, that's how you will take care of it. Either you say, asking yourself how many, what times x will give me x squared, or divide x squared into x, divide x squared by x, and you'll get that answer as well. So we see that the answer should be x, and normally we line it up with the same exponent on your variable. It doesn't matter because all of this space is for your answer, but normally you line it up with the same exponent of your variable. So then we take this and multiply it to x plus 3. Same way that we did, the 5 times 11, same process. So x times x will give me x squared. X times 3 will be 3x. Now, don't forget the next part of this process is to subtract, but you have to subtract both terms. So be careful here. A lot of people miss this or make a mistake here because they give, let me go green. They give this minus sign or they subtract the x squared, but they forget to subtract the 3x. So you have to be careful to make sure you subtract both terms. X squared minus x squared will cancel. And then here we have 10x minus 3x, which is 7x. Bring down 21. So like I said, the process is the exact same thing. We bring down the numbers, same thing. Then you compare your first terms again. What times x will give me 7x? Or look at it this way, 7x divided by x. Either way, you should get the same result, which is positive 7. Take the 7, multiply it to both of these terms out here. 7 times x is 7x. 7 times 3 is 21. Subtract. So 7x minus 7x cancel. 21 minus 21 cancel, leaves you with a remainder of 0. So your answer is just x plus 7. All right, make sure we're okay before we look at another one. Is everybody okay? Before we look at another one. All right, so next one, we want to divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. So let me erase this stuff so we can walk through it. First thing you want to do is to arrange this in descending order. I wish that too. All right, so I arranged my dividend in descending orders at the divisor. No divisor with the one on the outside, so dividend. So the 6x cubed minus x squared minus 5x plus 4. Once again, we're comparing first terms in each. So what times 3x will give me 6x cubed? And we see over here is 2x squared. Multiply that 2x squared to both of these terms on the outside. So that would be 6x cubed minus 4x squared. All right, don't forget to distribute that negative. 6x cubed will cancel, but that negative 4x is going to turn positive. So the result will be 3x squared. Bring down your negative 5x. Yep. Then you say what times 3x will give me 3x squared. And you see right here, that's just x. All right, multiply that to both numbers out here, both terms out here. So that would be 3x squared minus 2x. Distribute the negative. 3x squared cancels. Negative 2 is positive 2. So that's negative 5x plus 2x, which is negative 3x. Bring down 4. Comparing first terms, once again, 3x and negative 3x. What times 3x will give me negative 3x, and that'll be a negative 1. Multiply the negative 1 to both of these out here. So it's going to be negative 3x plus 2. Do your subtraction. And you're left with a remainder of 2. All right. So the way we write the answer, 2x squared plus x, let me bring it down some. 2x squared plus x minus 1 plus 2 over what we're dividing by, which is 3x minus 2. All right, any questions, any questions? All right, scroll up. All right, the next one we have x to the 5th plus x cubed minus 2 over x minus 1. So notice here we have missing terms. We're missing x to the 4th and x squared. All right, so we need placeholders. So these are just going to be things we put in place just to make sure that we are able to progress throughout the long division process with ease. Oh, I'm missing x to the 1st as well. I didn't put that one up. All right, so let me erase this. So you see what I did here? As far as putting 0 x to the 4th, 0x squared, and 0x. All right. So we have x minus 1, and we want to divide that into x to the 5th plus 0x to the 4th plus x cubed plus 0x squared plus 0x minus 2. And once again, you start off with the first terms in each. Ask yourself what times x will give you x to the fifth, and that's going to be x to the fourth. Take that x to the fourth, multiply it to each term here on the outside. So that's x to the fifth minus x to the fourth. Distribute that negative. So it's x to the fourth plus x cubed. And what times x will give you x to the fourth? That'll be x cubed. Multiply that to these terms out here. X cubed times x is x to the fourth. Times negative 1 is x cubed minus x cubed. Distribute your negative. I didn't write down that these cancel, but yep. So x cubed plus x cubed will be 2x cubed plus 0x squared. What times x will give you 2x cubed? That's going to be plus 2x squared. All right. Distribute the negative. All right, so that's going to be a positive 2x squared. Bring down 0x. Once again, what times x will give me 2x squared? That'll be 2x. 2x times x. 2x squared. 2x times negative 1. Negative 2x. Once again, distribute the negative. These cancel. I didn't erase this one. All right, so we have 2x, bring that at negative 2, so that's 2x minus 2. Then once again, comparing the first terms in each, what times x will give me 2x? And that will be plus 2. 2 times x is 2x. 2 times negative 1 is negative 2. And distribute that negative. Each one of these will cancel, leaving you with a remainder of 0. So this would be our answer. All right, questions on the process. So once again, you're just mimicking the long division process, but with your polynomials. Mimicking the regular long division process with polynomials. All right. So let's look at the synthetic division. It's a shorter process, still dividing, but it's a little bit easier if you can hold on true to the process. So synthetic division can only be used when your divisor is in the form of x minus c. And so what we mean by that is that your coefficient, the number in front of x, is 1, and your exponent is 1. That's what we're saying right here. So if anything's different, if it's 2x, and that's what I have right here in the green, just showing you here in this first one, you can use long division. We have x plus 2. In the second one, you would not be able to do long division because you have x squared. And then in this third one, you wouldn't be able to use long division because you have 2x. So if there's any number in front of x other than 1, you cannot do long division. If there's any exponent on x other than 1, you cannot use long division. I see long division. I mean synthetic. We're talking about synthetic division. Sorry about that. Cannot do synthetic division. All right. Questions on when you can and cannot use synthetic division. Let's scroll up. All right, so let's say if we had this problem right here, we want to divide x minus 3 into x cubed plus 4x squared minus 5x plus 5. All right, so we're going to set it up like this. Let me erase this so we can walk through it. No, I don't want to do that. All right, so notice right here, we're going to use the opposite sign of what we had originally. So if I have x minus 3, in this box should be plus 3, the positive 3, I mean. Then we're going to use all of our coefficients right here. So we have 1, 4, negative 5, and 5. All right. So the first move is to bring down the first number. In this case, is 1. Then you're going to multiply the number in the box to this number down here. And whatever that result is, you send it up here to be under the 4. So 1 times 3 is 3. Then you're going to add these numbers together. And that's going to be the process, and you continue to repeat that. So 4 plus 3 is 7. Then 7, excuse me, 3 times 7 is going to be 21. Add these together. 16. 3 times 16 is 48. 5 plus 48 is 53. And then necessarily subtract, circle that. And that last number is your remainder. All right. So once again, you bring down the first number. In this case, it was 1. Then you take the number in this box and multiply it times that number down here. And then you send it up above the line to be added to the next number. Add those numbers together and then repeat the process. 3 times 7 is 21. Put the 21 up here. Negative 5 plus 21 is 16. 3 times 16 is 48. Add those together. That'll give you 53. Last number right here is always your remainder. Then to write the result, you're going to start with one exponent less than the original polynomial. So originally we had x cubed. That means we're going to start with x squared. So we use these numbers as our coefficients. So that's 1x squared plus 7x plus 16 plus 53 over x minus 3. Remember, 53 is your remainder, so it goes over what you were divided by, which was x minus 3. Any questions? All right, let's do it again. So here we have 5x cubed plus 6x plus 8. We're dividing by x plus 2. So two things we want to make sure we recognize before we get started is that the first is that we're missing a term here. We're missing x squared. So you have to use 0 as a placeholder. And once again, we're using the opposite sign of what is initially given when it has x plus 2. All right. So negative 2 goes in the box, and then we're using 5, 0 for the placeholder. You know, that x squared. Got me to put 0 right there, the missing x squared term. Then 6 and 8. All right. First move. Bring down 5. Then we're going to multiply. Negative 2 times 5. Bring it up here, which would be negative 10. Add these together. It's negative 10. Negative 2 times negative 10 will be a positive 20. Add those together. Be 26. And negative 2 times 26. Negative 52. Add those together. 8 and negative 52 is negative 44. Once again, you start off one less than what you originally had. So now that's 5x squared minus 10x plus 26 plus negative 44 over x plus 2. So notice I put my negative up here with my 44. That's always the safest way to write it, especially when you have more than one term as your remainder. We don't have that, so I'm just trying to set you up for future things that you could come across. So I always put my negative up there with my remainder. Any questions? All right, I'll scroll up. All right, so the remainder theorem says if the polynomial f of x is divided by x minus c, then the remainder is f of c. So in other words, if I take c, not negative c, but the opposite sign, and plug it in to my function, that will give me my remainder. All right. Give me a chance to write. So given that f of x is x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. All right. Let me erase this. Don't worry about this. I'll come back to this. All right. So remember our last term when we do synthetic division, our last part of our answer is our remainder. So the remainder theorem is correct. I can use synthetic division to find the answer of what f of 2 would be. So now we want to be careful here. If they give it to you as f of 2, then what will go in the box is 2. Okay? The only time we did negative 2, or we use a negative, is when you have it with x. And that comes from the idea of, you know, if I have x plus 2 equal to 0, if I solve this for x, then it will be x equal to negative 2. So whenever they give it to you in this form, x plus 2 or x minus 2 or whatever, that lets you know you were going to use the opposite sign. But if they give it to you like this, then you just use the number that they give you. So they say f of 2, so 2 is the number that you'll use here, not the opposite. So, and that's what this was emphasizing right here. If I had x minus 2, then I would be using the opposite sign. If I had x plus 2, I would be using the opposite sign. But if they give it to you this way, you would just use the number that they give you. All right. So from there, you bring down 1. Two times 1 is 2. Add those together. It's going to be negative 2. 2 times negative 2 is negative 4. Add those together. That's 1. 2 times 1 is 2. Add those together. You get 5. So your remainder is 5. And remember, we're trying to test the remainder theorem. So what we're saying is f of 2 is equal to 5. So if that's the case, let's plug in 2 and see what happens. So remember, this is our function. And we're going to plug 2 into that function. And so that's what I did right here. So 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. 2 cubed is 8. 2 squared is 4. So it's 8 minus 16 plus 10 plus 3. And that will give you the 5 that we got right here. So those two 5s are the same 5s. So it doesn't matter which way you decide to go about doing it, but the remainder theorem states that you can use synthetic division to find the remainder, or you can plug in 2 into your function to figure out what the remainder would be. And that's going to matter and help us out when we do future exercises. All right, questions on that? Questions on the remainder theorem? So hold on to that connection. Like I said, that connection is going to help us out in future exercises. Also, the connection between solution, zero, and root, all of those words are interchangeable. We all know what solution is, but a zero is another word for solution. A root is another word for a solution. The reason why they call it zeros, though, is because that once you do synthetic division or when you plug the value into your function, if it is a solution, you would get 0 as a remainder, or in other words, 0 as a result. All right, so that's one way we would be able to check whether we have solutions or not. Synthetic division, did I get 0 as a remainder? Or, and we've done this practice before, plugging it into the function and getting 0 out. All right. Any questions? All right, the factor theorem. I think this is the last thing out of this section. Factor theorem. Let f of x be a polynomial. If f of c is equal to 0, then x minus c is a factor of f of x. And if x minus c is a factor of f of x, then that means when you plug c into the function, you get 0. And that's what I was just alluding to. And don't forget, notice the fact that we have the opposite sign thing going on here. When it's with x in that expression, you use opposite sign right here. Opposite number is what you will plug in. All right, in the green, I was just re-emphasizing what it means for an expression to be a factor of another expression. So when you look at x squared plus 7x plus 10, you will factor that out into x plus 5, x plus 2. Those are your factors. All right. And then what are the solutions? Remember we talked about basically when you look at x plus 5, if I want to solve for it, I will subtract 5 from both sides. That's where the opposite sign thing comes into play. You know, when it was x plus 5, if I want to know the solution, that would be negative 5. X plus 2, the solution of that would be negative 2. So those would be solutions or zeros. Remember, zeros and solutions are the same thing. All right. Then if we were to plug in negative 5 or negative 2 into this function, you know, I would also get 0 out. And that's what I did right here, just showing you that. Questions? Make sure we're all right. All right. Scroll up. Everybody okay? All right. So let's look at this next one. It wants to solve the equation. We have 2x cubed minus 3x squared minus 11x plus 6. And so our highest exponent is 3. And we're going to get 3 solutions. And I didn't say this other part. And they give us one of our solutions says given that 3 is a 0. So I'm going to erase some of this stuff and then I'll put it back. So we want to solve the equation for 2x cubed minus 3x squared minus 11x plus 6 equal to 0, given that 3 is a 0. So over here in the green, it was just a few things I wanted to point out before we actually get started, things we should look for, things we should see when we see an equation. Is that here we see that there are going to be 3 zeros in total because the highest exponent is 3. The highest exponent is 3. And then given that 3 is a 0, so that means 3 is a solution. And x minus 3, didn't take my wrist off. Down here, x minus 3 is a factor. And also when I plug 3 into my function, I get 0 out. So first thing we're going to do is use synthetic division to break down the function because we have one of the solutions, which is 3. All right, so let me erase this stuff. All right, so we have 3 that goes in the box. All right, then we use the coefficients of our equation, 2, -3, -11, and +6. Now, we know that 3 is a 0. It's not a question that they're asking us to prove it. So if 3 is a 0, then what has to happen is that 0 has to go right here, because that's what's going to happen, because 3 is a 0. And if that's the case, then we know that -6 also should go right there, because that's the only way we should get 0, or we could get 0. So if that doesn't occur, then somewhere we went wrong, right? Those two things have to happen. So you bring down 2, excuse me. 3 times 2 is 6. Add these together. -3 plus 6 is 3. 3 times 3 is 9. Add those together, that's -2. And 3 times -2 is -6. And then 6 and -6 will give you 0. So this is what we'll use moving forward. 2, 3, and -2. So before I scroll up, any problems with that, with the process? All right, solve the remaining equation. So remember, you always start off with one exponent less than what you originally had. We had x cubed, so now we're x squared. So we have 2x squared plus 3x minus 2 equal to 0. I can factor that into 2x minus 1 and x plus 2. Set each one of those equal to 0 and solve for x. That'll give us x equal to 1/2, x equal to -2. And don't forget that they gave you one. So if they were to ask you what are your solutions, you have to include 3 as one of your solutions, or they will mark it wrong. Because they ask you what are your solutions, or they told you to solve. So you have to put down 3, all 3 solutions. All right, any questions? Any questions? Are you done with this one? Can I scroll up? All right, next one, 15x cubed plus 14x squared minus 3x minus 2 is equal to 0. You want to solve that equation given that -1 is a 0. Let me erase this and walk through the process. All right, so they gave us -1 as a 0, so that -1 goes right here. All right, we're using 15, 14, 3, -3, excuse me, and -2. Don't forget, this lets us know we need 3 solutions. And also, since -1 is a 0, that means 2 has to go right here and 0 has to go right here in order for us to know that we've done it correctly. So bring down your 15. -1 times 15 is -15. 14 and -15, add those together, you get -1. -1 times -1 is +1. Add -3 and 1 together, you get -2. Then -1 times -2 is +2. And we get our 0 when we add those two together. All right. So use the 15, -1, -2 to come up with your new equation. 15x squared minus x minus 2 Factor the polynomial, you get 5x minus 2, 3x plus 1. And remember, if you're not good with factoring, you can always use your quadratic equation. A quadratic formula, not quadratic equation, quadratic formula. Still give you these two solutions. Your result would be 2 over 5 and negative 1 over 3. And once again, don't forget, the negative 1 they gave you is a solution as well. All right, questions. All right, everybody good before I move off? All right, let's look at 3, 4. Do I want to get started here? Hold on, let me map this thing out. So we have 3, 4, 3, 5. Three, 6. 3, 7. Okay. 4. Okay, so we can pause right here instead of starting a new section. Yeah, we'll pick up at 3, 4 next class instead of starting a new section. Yeah, want to give you guys a chance to digest that and go from there. So try the stuff out. See if you have any questions. See if you have any concerns, and you know, hit me with them whenever you get a chance. Email or next class, and we can go from there. Next class we'll pick up at 3, 4, and move forward. Any questions, concerns, or comments before I let you go? All right. Well, you guys have a good one. Be safe. Have a great weekend, and I will see you on Monday.
I have a good weekend.
Thanks. You do the same. Somebody said they had a question?
Yes. I emailed you about my Chromebook. I just received my new Chromebook from the school, so I wasn't able to take the test.
Mm-hmm.
But when I went to go take it, it said it was locked.
That's because the due date is past. It's over.
Okay.
I'm just messing. When did you email me?
I got my computer Tuesday.
I must have missed that email. Okay, but yeah, that's not a problem. If you email me, I'll respond back to the email. I'll open it up. You know how much time you think you may need? How many days or whatever? To get
No,
back?
I was gonna do it today.
Okay. Ruffin. Yeah. How did you email vtucker@tcc.edu?
Yeah, through Canvas.
Yeah, I don't see. Hold on, let me. I just want to make sure our communication is straight. Okay, I see it. I see it. Somehow I missed it. But that was yesterday that you emailed me. Okay. Yeah. So I will go in there and open that up for you.
Okay,
Now.
thank you.
All right, not a problem. All right, take care.